Hello, everyone, and welcome to another mini sky tonight. So here we are going to wrap up our moons of the solar system tour with the unique moons of Saturn. The reason being why I'm going to end it here at Saturn is because many of the moons of Uranus and Neptune haven't been fully explored much. They've had passing bys from different spacecraft like New Horizons that went out towards Pluto and were able to capture some images, but not a lot is known about Uranus and Neptune. But if people are interested in me checking out the moons of Uranus and Neptune, I'd be happy to do it and try to do a little bit more research. Just leave it down in the comments if you'd like to check out these unique moons around the two furthest gas giants. But for now, I'm going to try to stop it up at Saturn because at least with Saturn, we had the Cassini spacecraft who was able to take a look at some of these unique moons and even discovered new moons around Saturn. So today, Saturn has over 83 moons. And I'm not going to discuss all of them because all of them are unique and different in their own right and aspect. And some of them are weird potato-shaped moons. But today I wanted to cover over some of the biggest moons. Now, believe it or not, I did a video on the moon Titan. So if you want to check out the moon Titan by itself, I'll leave a link up here and you can check out Titan on its own. So today I wanted to discuss about 6 of the other big moons: Rhea, Iapetus, Dione, Tethys, Enceladus, and Mimas. And so we're going to look at these unique roundish moons and some of the unique features of these moons. So first up, Rhea. It was first discovered by Giovanni Cassini, and it was one of the stars of King Louis. Now, Giovanni Cassini was trying to impress the king at the time, so he named some of these quote-unquote stars of Saturn in honor of the king. And this is also known as Saturn V because it's the 5th planet or the 5th moon around the planet Saturn. It's named after the Titan Rhea. So since Saturn is named after the king of, or the father of all the gods and goddesses in Greek and Roman culture, he also fathered a bunch of other beings known as Titans. So many of the moons are named after the children of the father of the gods. One orbit for Rhea is roughly about 4.5 days. So every 4.5 days, Rhea goes around Saturn. It's tidally locked, so one side of Rhea always faces Saturn. And it has a radius that's very small. Many of the moons of Saturn are smaller than our own moon. And it's really, really cold. But one of the unique features they found on Rhea is that it has rings. Like some of the material that was from the ring system had pulled off and went into orbit around Rhea. So it's possible for rings to exist around moons. Next up is Iapetus. It also was discovered by Giovanni Cassini, but this name was suggested by John Herschel rather than being one of the stars of King Louis. It was after Cassini discovered this one, it was John Herschel, who was a colleague, that suggested to name it after another Titan. It was also named Saturn 8 because it was the 8th moon around Saturn, and named after the Titan Iapetus. It has an orbit that's much longer because it's not as close to Saturn as, say, for example, Rhea. It has an orbit roughly about 79.3 days. But one of its unique features is it's often referred to as the yin-yang moon because on one side it's completely dark as asphalt, but on the other side it's white snow. So hence why it's kind of got the yin-yang effect going. Next up, Dione. Also one of the other stars of King Louis, and it was the 4th planet around Saturn. And so hence it has an orbit that's 2.74 days. So it orbits Saturn relatively fast. And it's also incredibly cold. And for how far away it is from Saturn, is a similar ratio from how far away the moon is from the Earth. So that was one of the unique features of Dione. Next up, Tethys. Also one of the stars for King Louis, but it also has this huge gigantic crater on its surface that really made it stand out. And it's a highly reflective, because most of the other moons kind of have this dark surface feature to it. And they were kind of figuring out why, but they believe that Saturn's outer ring, the E ring, was basically being pulled away by Tethys, and that material fell onto the surface, giving it its highly reflective look. Enceladus. This was one of the moons that was actually discovered by William Herschel rather than Giovanni Cassini. And it was the second moon closest to Saturn. And it was very difficult to see because since it has an orbit that's relatively fast, it was sometimes difficult to capture it in a telescope. And because it's really small, earlier it was so tiny, it was really difficult to see. It looked like a tiny little dot, and often Cassini confused it with a star. It was Herschel who had a much more powerful telescope that was able to differentiate it as that, hey, no, this is an actual moon. And just to give you a rough idea in terms of its radius, it's about as wide as the state of Arizona. So it's relatively small. But even though despite it's cold, one of the unique things is that it sprays Saturn's rings with new material. So could it be due to tidal heating or some type of internal heating of some kind that's causing Enceladus to be able to have ice geysers to replenish the rings? And last but not least, Mimas. Now, this was also discovered by William Herschel because, again, since it's so close to Saturn and it was so tiny, it's so small, it's 415 kilometers, it's smaller than even some of the states in the United States, that it was really difficult to see. But one of its most prominent features is the big, huge crater, and of course, later on, due to pop culture, it was been nicknamed the Death Star moon. In fact, some people believe that even George Lucas took his inspiration from this moon for the design of the Death Star. All right, let's look at the surface and the compositions of the different moons. Now, in past, I've looked at also geological features and things of that nature, but for many of these moons, they didn't get some of the, how to put it, didn't get some of the attention as the other moons did. So we're just going to look at the surface and composition, because most of Cassini's mission was focused around looking at Saturn itself and the ring system, as well as the moon Titan. And it just did a glance over of the different moons along the way. It's hoping in the future we're able to send spacecraft to Saturn to look at these moons even further. All right. So let's look at Rhea. It's heavily cratered, but dark areas, so like these dark brown areas that you can see over here on the left side of the image, indicate a younger surface. So that maybe it was due to cooling, or that it basically experienced thermal contraction or something of that nature. And they noticed that fracture canyons expose fresh ice. So like in the dark area, you kind of see this white line in the center there. That's a fracture canyon, and it exposed fresh ice. In fact, Rhea is thought to be 75% water ice. So they're ice balls. And it possibly can have a liquid ocean too. Next up, Iapetus. It's also got this walnut-shaped appearance because along this perimeter around close to the equator is this huge gigantic ridge along the equator of the moon. Now, astronomers believe that it could be one of two things. That one, it could be just Iapetus was rotating so fast during its early formation that it basically squished it to where it created this ridge. Or it could be that it was a ring that did once exist around Iapetus, and that it basically collapsed and fell in that long line. But it's 20% rock. So even despite this dark material, most of it is ice. And so these dark areas that are on the surface that you can see is basically caused by areas that are heat up, and it basically melts the ice, and then it sublimates into a thin atmosphere on the daytime nighttime lines. And then over on the nighttime, that thin atmosphere then starts to begin to snow on the other side, creating the white that you see. So one side is being heated up and basically sublimates and snows on the other side. Next up, Dione. It's 2/3 water ice and has a really dense core, which astronomers believe that it could be composed of silicate material. And it has like these wispy, bright canyon lines, and it's due to possible cracking. Could this cracking be due to internal heating and or possible cooling? They're not sure. But one of the things that they noticed that is that Dione was important because it keeps Enceladus locked in its orbit the way it is. So as Enceladus goes in its orbit and gets close to Dione, it would speed up and then continue in its orbit at the same stable space. And then would start to eventually slow down a little bit, and then it gets to Dione and speeds up again, and it keeps it in a stable orbit. Next up, Tethys. Mostly water ice. So most of the moons of Saturn are this water type material. And it was basically the reason being it has all this bright surface features is because most of that material is picked up from Saturn's outer ring, the E ring. It shows that it had possible tidal heating in the past, because as you look on the surface is relatively smooth and it doesn't have a lot of craters. But one of the biggest craters that is prominent on Tethys, as you can see in the top upper right portion of the picture, is called Odysseus, named after the Odyssey. And it's a large crater that's over 400 kilometers wide. And it also has this long crater that goes from the North Pole to the South Pole. It's over 2,000 kilometers long. It's called Ithaca Chasma. And it's a huge canyon that's thought to be created by thermal cooling. Next up, Enceladus. It has really smooth areas, so that some areas that you can see a lot of craters in some areas, but in others it's really smooth compared to certain other areas. And they noticed that this particular moon has ice geysers, and from the fractures that you get these ice geysers of material that is being sprayed out into space, which then is then picked up by Saturn's outer ring, and it replenishes the ring system. And those dark kind of blue purple lines are fractures in the surface, and they're sometimes nicknamed tiger lines. But from these fractures and these ice geysers, we're able to detect different types of materials in the geysers, such as water, carbon dioxide, methane, ammonia, and even nitrogen. So here is basically from the Cassini spacecraft taking an image of some of the ice geysers that are pulling out from these cracks. And over to the right is a simulation image where showing like where the lines of the cracks indeed are. So these geysers are spewing up from these cracks. And last but not least, Mimas. It is heavily cratered. And of course, the largest crater, which is supposed to represent the Death Star ray, is nicknamed Herschel. But they notice it has a lot of libration motion. Now, libration basically means wobbling of the moon. Our moon does that. It's sometimes called the drunken moon, but it's basically wobbling because it's rotating on a certain axis. And it also has unique internal heating. In fact, just a bit of a nerd bit, when they did some of the internal heating, like one side was kind of really heated up, even though it's so far away. And they noticed that given where it's located and heated, it kind of looks like Pac-Man. So they had a little bit of fun with it. Okay, so who has visited these moons? The first one was Pioneer 11, who did the first flyby mission and was able to take a couple of images of the different moons as it flew by. And of course, Voyager 1 and 2 did, but Voyager 1 mostly focused on the rings and the planets, whereas in Voyager 2 was able to take a look at a bunch of the different moons, especially Titan. And of course, Cassini-Huygens was the longest mission around Saturn and was able to send a probe into Titan to look at the surface of another moon. And it was able to confirm many of the new moons that we see today and give us some of the information that we know about many of the moons around Saturn. So are there any future missions underway? Yes. One of them is called Dragonfly, which is supposed to be like this unique little lander that's going to go onto the surface of Titan and basically explore around and look at some of these different moons. And in 2026, they're supposed to look at basically the habitability of Dragonfly. And next up is the Titan Saturn system mission, which is going to look at Titan and its atmosphere, along with some of the different moons. And the Enceladus Explorer, which is going to look at the ice geysers. So hopefully we'll be able to take up and look at some of the unique features of these moons even long after Cassini. So where can you see Saturn and some of these unique moons? So if you look towards the east, towards the southeast, roughly around about 9 o'clock or so, you should see two bright stars. The lower one is Jupiter, but the upper one is Saturn. So you'll be able to, with a pair of binoculars or a small telescope, look at the planet, see some of its rings, and you'll notice that a couple of the stars will be nearby it. Those stars are some of the moons of Saturn. So this is kind of a bit of a tour on some of the unique moons of Saturn. So if you have any questions or comments, leave it down in the comments below. If there are topics you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.